Okay, so for those of you that don't know me, I am the Director of Graduate Studies and Mentoring here in the Chemistry Department. And my job is basically to help oversee the graduate education that you guys are getting, as well as helping to, I don't know, sort of do new initiatives. And I work with our senior grad coordinator. Did I get that right?
No.
I never get it right.
We were going with the director.
Oh,
Assistant director.
Assistant Director of Graduate Studies and Mentoring, Dee Dee Ryan over here. So Dee Dee knows all of the administrative rules, and so she can help you out with all of that stuff. And she and I work together very closely on grad studies and grad admissions and all of that. Basically, to try to help you guys have a great experience while you are here in our department. So that's kind of our job, is we are here to help you. Okay, so why don't we go ahead and get right into this? Sorry, I'm not good at clicking. I don't know how to use clickers. I'm sorry. Is this like,
Do you want me to open for you on the?
no, I mean, I can click the computer. How's that? All right, does this have a laser pointer? No. Okay, that's useless. All right, it does have a laser. Oh, you see that? Huh? Okay, I'm just gonna point. All right. So here we're doing our prelim exam overview, and it's presented by Iota Sigma Pi. So thank you all for bringing all of this information to all of the students that need it. And so this is our little advertisement. Dee Dee likes to give things fun names. So this is our Prelimapalooza. Okay, you may have done the registration orama. Do you remember that? And what was the one we just
Planet Bonanza.
the Plan of Bonanza? All right, so this is Prelimapalooza. All right. So the general purpose of the prelim exam is to advance you on to PhD candidacy. So the idea is that we are giving you this exam to make sure that you've gained all of the foundational knowledge and skills that you need to be successful as a PhD candidate. And so the basic requirements that you have to complete before taking your prelims are that you have to have an approved plan of study. That's very important. You need to have completed your coursework with no grades below a C, and you have to have a plan of study GPA of 2.8 minimum. So if you do not have 2.8, you may not take your candidacy exam. So this is something to pay attention to when you are putting together the courses that are on your plan of study. And then you also, of course, have to have passed your foundational course with a B or better. Okay, so here are the components and the timeline. So there's kind of a lot of moving parts to advancing to candidacy. So the first thing that you generally do is you write your second year annual report, and that's generally due in August at the end of the summer semester. You can submit it to your committee earlier if you want to, but it has to be done by the end of the summer term. Along with this research report, you're going to submit a written one-page specific aims document. And the written one-page specific aims document is basically a very short summary of what you want your original proposal to be about. And this is very typical. Like when I submit my proposals to NSF, NIH, DOE, whatever, we generally submit these like white papers, they call them, but they're very short abstracts of what we're going to talk about. And so the idea is that you give this one pager to your committee and they'll either say, this idea is awesome, or this is the worst thing I've ever seen in the world. Or they'll probably do something in the middle, which is like, this is pretty good, but I might tweak it in this way or that way. And so the idea is to get feedback on your topic before you start writing your full proposal. So that way, if they're like, this topic is never going to work, or, this really isn't like the proper scientific depth or something like that, like they will give you that feedback. So you don't spend all the time writing a report that's not going to be. So that's what the one page specific aims is for. And so you'll submit that at that time as well. So then once we get to the time when you've scheduled your exam, you're going to submit your written original proposal, and that's going to be submitted 2 weeks before your exam date, before the oral exam. And then you're also going to submit your dissertation research summary. Now, your dissertation research summary probably has a lot of overlap with the second year report research summary. So you can either probably like use the research report as part of that. So you probably don't have to do a whole lot more unless like you have made some major discovery from August to like whenever your exam is, probably like October-ish. Like if you have made some major scientific discovery during that time, you may want to write some additional words about this awesome discovery. But for most of you, it will probably just be kind of a re-release of your research report. And then during the actual exam time, you're going to give an oral presentation, and that's going to be all about your original proposal, and that's going to be kind of like the major part of the oral exam. And so you'll give slides, or you make slides and you give a talk and you'll answer a lot of questions. And then you'll also talk about your research a little bit at the end. And so that is that, so that the committee can be up to speed on what you've been doing in the lab and kind of like where things are going and what your like major thesis project is going to be. Okay. So the second year annual report is going to start in the summer. And guess what? We are officially in the summer. It might not feel like it outside, but how many of you are second years? So for those of you that are second years, we are officially in the summer. So it is time to start thinking about your annual report.
And I will send out guidelines.
And so like we said, you're gonna submit these documents as part of your second year report. So start thinking about that. So you're gonna submit your second year research report, which is the foundation for the dissertation research summary, right? So this is what you're gonna be the research part of your oral exam. And so you're basically gonna summarize your questions and your accomplishments, what your goals are for the next year. And then like a little bit about like your future plans, like I want to be a professor, or I want to go to industry, I have no idea what I want to do, I want to stay here forever, like whichever of those like you're feeling like kind of right about that a little bit. And it's generally a Jack style 3-page communication, right? So we like the Jack style because it looks super professional. And the font is like so tiny, you can fit so much stuff in there. So that's why the ACS likes it. That was a joke, by the way. The thing about the tiny fonts, that was a joke. All right. So in addition to your second year report, you're going to submit your one pager. So your one pager is going to be a broad outline of your original proposal idea in an ultra condensed format. Hence the title, one pager. Okay. Like you do not need to go into tons of detail. We just want to get an idea of like, what is the main goal? Have you thought about some project objectives that you're interested in? And kind of like what how is this contributing to the field of science broadly, right? So the topic of your OP and your document is flexible and needs to come from you. So it's your idea. And you don't have to have everything fully flushed out. We just kind of want to know like what direction you're heading in, and then your committee members are going to evaluate and indicate if the topic is suitable and if it's not suitable. My guess is if it's suitable, you might not hear from them, but if it's not suitable, you'll definitely hear from them. So, you know, you can kind of think about that. But, you know, we just kind of want to have an idea of like what you're thinking along the lines for your topic. Okay, and then you have to schedule your preliminary exam date, and you should try to make sure that you do this well ahead of time because faculty are annoying and we have, well, for many reasons, but one of the reasons is that we're busy, we have a lot of meetings and things here or there. You got to coordinate 3 different faculty schedules, so you definitely want to start thinking about this early. You've got to have your exam done by the 17th. And don't make it for like the 15th because if you have to do corrections or you know you have to write a little bit more in your report, maybe the committee wants to see that, like you don't want to only give yourself 2 days to do it. So try not to make it like that week. Also, usually during this time of the year, things are quite busy, especially in the front office. Okay, so once you send out your poll and you figure out when your faculty can meet, you want to email Jordan with your exam date and time and the name of your committee members. Please don't forget to do this because this is how you get everything official. And so Jordan will book your exam rooms. You don't have to worry about finding a room or anything like that. And she'll submit your forms to formally schedule your exam, right? So once you figure out the faculty schedules, you let Jordan know and she'll take care of all the administrative stuff. So after you do that, well, probably before you start writing, or you should start writing before you schedule your exam, but you want to start writing, you giving yourself a good amount of time to do that, right? Because you've got to submit them 2 weeks before your oral preliminary exam. So you obviously don't want to be waiting until the last minute. But when you get them done, you can email the documents to Jordan, and then Jordan's going to distribute them to the faculty. And so the faculty have time. We'll have time to look at them before they go into your oral exam. Does that mean I should talk faster?
Might want to just point them to some of the stuff in the
Okay, you have a packet?
guide, the preliminary examination.
Okay.
Read through the learning.
All right. So this part is important. Before you start, talk to your PI about the divisional expectations. You are going to get some of those expectations today, but before you start writing, you want to talk to your PI. One, let them know, I'm going to be writing my OP, and then talk to them about sort of what the divisional expectations are. And things, you're going to hear a lot about what to include and address in your original proposal. So I'm not going to go over that too much in detail, but basically state the problem, talk about why it's important, and then talk about how you're going to propose to address the problem, what experiments you're going to use, and then what types of things you might run into during this. And so it should outline a full research program, but should not include an extensive review of past research. Right. So we don't want to test you on your ability to read the literature. This is really about your own idea. Okay. So this dissertation research summary, this is what you're going to hand in so that the committee can look at your research. And so they're going to give you, or you're going to give an overview of your research progress. And then, you're going to use your second year report, and you might have some supplement if you want to add some additional work in, but basically, this is going to have the basics from your research report that you handed in already. So on the day of the exam, you want to get there and get set up, dress professionally, no jammies, please. And then you're going to give your original proposal presentation. People are going to interrupt you. And at the end, you'll do your required research assessment presentation. Okay, and so we'll talk about this more, but you've got to be prepared for committee questions, right? The whole point of this exam is for us to see how you think on your feet. So make sure that you are really thinking about that and practicing that, right? That will help you prepare for questions and things like that. And you need to know going into this exam that you're not going to know all of the answers to our questions. We're definitely going to come up with stuff like out of left field that you definitely have not thought about. That's kind of our job to do that. So don't worry if you don't know all the answers, because the idea is to think on your feet. Oh yeah, we're going to practice giving professional presentations. This is a recommended structure, so you don't have to stick to this. We want to do a couple minutes of intro, why you're doing the research project you're doing, then give us a summary of like the main things that you have accomplished during your time, and then wrap it up with some future plans, right? Because the future plans are what you're going to be doing when you pass the exam. So you do want to make sure you put in a couple minutes of what your future plans are. And then we will kick you out of the room. We will talk about you. and then we will decide what we want to do. So we're either going to pass you, that's easy. We're going to fail you if we don't think that you're ready. Or lots of times, more often than not, we will be undecided and we will say, okay, well, we don't really think the student covered this or that. Well, let's have them write another page about this issue that they didn't, they didn't discuss or something. So we might give you an additional thing to write about, and then we wouldn't report the decision then. We'll wait until we get this final document from you, and then we'll make a formal decision. All right, questions about the process before we get into some division-specific material? I made that super clear, or you're all so scared you don't know what to do? It's the scared one, isn't it? Don't be scared, okay? It's part of the journey.
Really and truly read that preliminary exam. We put a ton of work into it. It's got like a lot of information about the things you really need to incorporate, why you're incorporating them. It's a very nice roadmap for how you should be doing a prelim.
Yeah. All right. So I get to start the divisional talk, the divisional presentations, because they all have good advice. Why is everyone leaving?
Well, because they're anticipating that you're going to give a brilliant inorganic.
Okay.
They don't, yeah.
That's fine. If you guys want to move up or sit down or something, please do that.
All right. I'm going to swing off.
All right.
I know.
See you later. Thanks. All right, that was weird. So there's like a ton of first years.
I think like well the second year class is pretty big.
Yeah.
And
I don't understand why they're leaving.
I think it's just because with the divisional thing we tell them that they can
That's fine.
come and go.
Yeah, that's why I said you should stay for all the divisions. I literally said you should stay for all the divisions while everyone was leaving. That was fun. Okay. All right. So I'm here on behalf of the inorganic division. And so in the inorganic division, we are very interested in students doing a topic that is not directly related to their thesis work. So some divisions don't mind if it's related. In inorganic, we like you to do something that's not related to your thesis work. And so we want you to choose a topic that interests and excites you, and you got to find something that is not related to what you're currently doing in the lab. And so the idea with this report is that you want to check in with your research advisor, check the grad student handbook, see what the divisional guidelines are, length, all of that, whatever. For inorganic, I usually tell people 10 to 15 pages, double space. If you want to do it single space, you can make it shorter than that. But we want to make sure that you are kind of doing all of the technical aspects correctly for this. So I always recommend to students that you come up with a few ideas and research them simultaneously. Because at some point you're going to figure out that one of these projects doesn't work. And if you put all your eggs in that basket, then you're going to have to like start completely over. So think about like a major scientific area that you think is really cool, and then start coming up with different ideas within this realm that you can research at the same time. And use a lot of figures in your report, right? So it's a lot easier to explain things with pictures than it is with words. So make sure you put some nice figures in there. Make sure you reference your figures if you're not making them. If you're taking them from something, make sure you reference them. Make sure you actually propose something. This sounds kind of funny, but I've definitely had students that have given more of a literature review than like actually proposing something. So make sure that when the committee asks you what the first experiment you're going to do in the lab is, and they will ask you that if you're in an experimental group, make sure that you have something to say about this. You are not in this alone. I know it's scary, but you're not in this alone. So get help from older graduate students, either in your groups or other groups. You can ask other professors. I've had students that have come to me from other groups that want to do like rare earth separations or lanthanide luminescence or something like that. And they've come to talk to me about it because I know a little bit about that. So you can go and ask other professors that maybe would be in the area that you're interested in. You know, you can pick their brains, you can learn some things from them, and certainly from their graduate students. And most of the graduate students are really going to be empathetic to you because they have gone through this process, right? So they're going to want their peers to be successful. Please have someone proofread your report for you. Don't just like hand it in without looking. And make a talk that's engaging and recognizable to your report, which means after you hand your report to Jordan, don't change the topic in those 2 weeks because that's not going to go well, right? You've already spent several months writing this report, so make sure that your talk is interesting, engaging, and that we will recognize some of what's in your talk from the report. Now, that being said, if you're making your talk and you're like, oh no, this idea is not going to work, what am I going to do? In that case, then you may tweak it some to say, oh, we realize this might not work. This is what my plan is instead, or something like that. We totally understand it when ideas don't work. We totally understand that, you might be working through something and, lightning bolt might hit you and, you have different ideas or something, but it should be somewhat recognizable to your original topic. Make sure you practice your talk in front of a group of people. What my students tell me is that when they practice their talk in front of their friends and peers, those people are often harder on them than their professors, right? So practice your talk in front of a group of people. You tell your friends, you buy them some pizza, and then you give them the opportunity to ask you really hard questions. I think most of them will take this opportunity. So make sure you practice, and you want that practice of thinking on your feet, right? And this will allow you to do that. And then dress professionally, of course. And I say dress professionally because, of course, I've been to exams where people haven't dressed professionally. Okay, so those were all the do's. Let's talk about the don'ts. So don't forget to reference the work of others, figures maybe you've borrowed or something like that. You want to reference this report liberally. We want to make sure that you know how to do that, and also that you are giving credit where credit is due. Do not fabricate data to show us what you think the outcome of your proposal would be. We are not supposed to teach you to make up data. So don't make up data, but you can say, oh, I expect something like so-and-so had in this paper, and you could put that figure, but we don't want you to make up stuff, right? So you can say what you think would happen, and reference those images accordingly. Don't make your report super long because nobody wants to read all that, including your committee. Don't start your report the week before it's due. Give yourself ample time to read the literature to make sure that you're understanding the significance and the impact of your work. Give yourself plenty of time. And that way you won't be as stressed. Also don't make your talk really long because, as I said, we're going to stop you and we're going to interrupt you and we're going to ask you questions. So if you make your talk really long, you're not going to get through it. Like, we generally will stop you after an hour, 20 minutes or so. So make it such that if we interrupt you, you can still get to the main points of your talk, right? You don't want us to just ask you questions on background. That would not go well. Don't think you have it and don't need to practice your talk. I don't care how good of a speaker you are, you always need to practice your talk. I practiced what I was going to say about this yesterday. I practice conference talks. I practice university seminars because I think that I am less nervous and I do better when I practice. So really make sure you give yourself time to practice your talk and then give yourself time to make changes that your friends give you after, from the practice. Don't dress like you rolled out of bed. Don't think you have to do it by yourself. I already told you, like, this is kind of a team effort. You get help from lots of people. So please feel free to engage others in this effort with you. And of course, don't disregard the divisional guidelines. So in keeping on time here for inorganic, we're looking for something different than your thesis work. We're looking for about a 10 to 15 page report that uses figures and is well referenced. We're looking for you to do something that you think is cool because We want you to be enthusiastic when you present this report. And I think if you do a nice job, I think you'll really kind of take ownership over what you're doing. And I do know some people that have used their OP proposals later on. They've kind of used that as like a jumping off point for proposals they need for jobs and things like that later. So if you do a nice job, then it could kind of inspire your interest in other fields later. Okay, do you guys have any questions about inorganic or about the general guidelines? Yes.
The figure generated by AI, how to reference.
Yeah, so you should probably reference like the prompts that you put in to generate the figures. I don't know, Dr. Wasserman, do you have ideas on this? Because I don't use AI that much. Yeah, so put in the program that you use, put in the prompts that you use to generate the figures. Yes.
Pick up the subject for the OP.
Uh-huh.
So it should be different than our presentation.
Yeah, are you an inorganic?
Like similar or like in the same thing with the previous research that we already did or with that?
Yeah, you should make it different. We want you to learn something new. So we don't want you to write an OP based on like your undergraduate research or something like that. We would like you to really stretch yourself and come up with something different.
There is some overlap. Like for my research and OP,
Uh-huh.
some overlap.
Uh-huh.
Is that okay?
What division are you in?
Biochemistry.
Biochemistry? Yeah, I don't know. Dr. Lyon will be here later, so you can ask for that.
For inorganic is not.
That's right. Yeah, I mean, don't forget, like if you make your project too close to your thesis topic, like that could be a reason that we could fail you. So you don't want to spend all that work. And that's part of why we do the one pager, right? So if you give us the one pager and we feel that's too close to your thesis work, we'll tell you this is too close, make it more different, and then you'll have the opportunity to do that. Right? We don't want you to doom yourself from the beginning by choosing a topic that's not far enough away. All right. Anybody else? I think it's time for Dr. Way, right?
Yep.
Dr. Wasserman, Dr. Way.
Okay, all right.
Great. All right. Thanks.
Okay, wow, amazing. Okay, so I'm going to actually do my best to keep the schedule ahead of time. So I'm only going to show 2 slides, and that way I can take my time and go into some detail. Let's go to the first slide. Oh, should I use it?
Yeah.
Okay. All right, so the materials division, being multidisciplinary, really covers almost just about anything you can think of, right? And so in a sense, it's a very generic approach to how we would recommend people to design their OPs. Okay. But the 4 bullet points you see here are the general expectations of what you would be asked and what's expected of you when you design your OP. Okay, and so those criteria is originality, obviously, because it's an OP, right? We would like for you to strike a good balance between breadth and depth of knowledge. Okay, and I'll talk about that in a minute. Okay, and be prepared to answer questions on chemistry basics. Okay, general chem, maybe a little organic chemistry or physical chemistry related to your OP topic. This comes up almost every time. Okay, and so having a review of things that you may have forgotten about from years ago may be actually a good thing to do. Okay, and the last part, of course, is the real meat of an OP is how robust your idea is, right? And so you performing a critical analysis, what do you think can work, where limitations are, you have backups in case your most ambitious plan has some problems. Okay, now I heard a question when I first came in that I think I can address, right? And probably applies to almost everyone's division. Okay? And that is with the graph below. Okay, and so this is a modified graph from one of our class notes. But you'll see that there's a curve that slopes rather steeply upward the closer it gets to the 0 point on the x-axis. And so the x-axis is how close your OP topic is related to your thesis research. Of course, this is somewhat subjective, but I think most people can tell when there's somebody or something, right, that's being proposed, which is pretty close to your already experiences that are within your domain. Okay, and so it could be generic, it could be not be very specific. But the point is this, right? The further away your topic is from the OP, the more reasonable your questions are likely to be during the OP time. But as you get closer and closer to this overlap region, the questions that come up during the OP are likely to become increasingly. Okay? It's not a matter of outright fail, really, right? At least we hope that will be the case. But I would say that in the case where there's substantial overlap to what we believe you know already from past research and your new idea, right? This idea will go up. Unfortunately, in the challenge level of questions, right, we start at reasonable. Okay. Although we'll give you a few easy questions for warm up. Okay? But what you want to target, whatever you want to target, something in this range over here, right? Not so much over here because it's hard, and definitely not over here because this creates progress. Okay, now here's some specific tips that I thought about just as a take home that might be a little bit different from others. And one is that, and particularly for something that has some physical basis and materials, is that it's very good in your OP to design goals and sub goals that have some sort of quantitative outcome, right? And so just to throw out an example, let's say you want to design something that's going to be more safe in terms of its use, okay? But that can be very subjective. You have to quantify what it means to be more safe, okay? More likely, you'll be going after some sort of function, some output function, brightness or strength or something. That might be all right as well. But if it's something that's, in a somewhat toward the less hard sciences, right? It could be biological or it could be even related to social aspects. Just be careful to make sure that you quantify the outcomes that you're expecting. Here's where we start. Here's where we end, right? We can actually measure an improvement in my idea. The other thing is that, especially if it's a multidisciplinary topic, you'll probably be using a number of tools, right? Or borrowing assays, which is very common. Okay. And we just want you to be sure that you know the importance of the assay that you're using, right? It's easy to pull something up because it sounds good. We may ask you questions about the assay or the technique or the tool and see if you understand why it's relevant to your project and what it can and cannot do, right? Scopes and limitations. Okay, and this is very important for every aspect of a measurement that would go into your OP design, right? So those are very specific that I wanted to share. Now, the remaining bullet points you're going to hear over and over again. Some of them you'll hear over and over again. Some of them will be frequently. And I forgot to change my title. It's not really comforting thoughts. I mean, just some thoughts, right, to keep you from, going into despair or going crazy. Okay, but let's go ahead and go through them. So it's always hard to get started. Okay, it's mental churn. We like to call it mental churn. And so coming up with your idea is a hard part. And very often, I mean, almost all the time, your first idea is just not your best idea. Okay, so start early. Start this week thinking about ideas, right? And just, you can replace those ideas as you continue to put thought in, but think about it, on a very regular basis and work through a lot of bad ideas. Expect to get a lot of bad ideas. I have many bad ideas every day, okay? And I just have to learn to filter them out. And I keep the one good idea that happens every 2 or 3 days. Okay. All right, so your first idea is not usually the best one. Just be prepared for that so that you can really start to focus at a reasonable time frame, the idea that is worth working on. Okay? And hopefully this is an idea that fascinates you, right? It's no fun to work an idea that you don't really have an interest in. Okay, so something that you actually like to think about or something you want to learn more about. Okay, and if you do that, your idea, the OP idea, will just naturally shine through. Okay, and so this is really very important. It has to be enjoyable, right? The process of doing research on the idea that you want to show off. Okay, and the other thing is to be able to choose a problem that's clean boundaries, right? You don't need to be, you don't need to save the world or cure cancer, right? Just choose something where there's a definable outcome, right? And you believe it makes a good difference, and your OP will explain why it will make a significant difference. Okay, so idea generation. Now, when it comes time for presenting your ideas, right, you have both the written document and the presentation. And so I think that Dr. Bart already said this, but you want to make the OP document easy to read. And most importantly, you want to put in a lot of pictures, okay? Because nobody likes a wall of text, right? So use pictures, use appropriate headings, right? It also applies to your presentation slides. Okay, just make it easy and smooth to read. And the best way to know that your on track with this is that when you have a draft, maybe a late stage draft, share it with your friends or your lab mates and just have them go through it and see if they can understand what it is that you're trying to explain, either in writing or in the presentation. Most people focus on the presentation, but I would say the writing a document is also equally important because your presentation really springs from that written document. Okay. And of course, you're going to do them a favor, right? You're also going to read their OPs and listen to their presentation. Okay. And so if you cannot understand what they're saying, or they can understand what you're saying, or trying to say, right, it's very likely that we won't understand either. Okay. The faculty committee, thesis committee, right? I just want to emphasize that we are definitely not out to get you. Okay. Point number one. Point number two, we're definitely humans. Okay? And as all humans do, we make all sorts of errors. We're far from perfect, right? We're easy distracted during the OP, right? We ask questions and then go off on a tangent, right? We'll forget things that you've said. Okay. And so don't allow something that goes off track to distract you from what you need to do. Okay. And so if an OP member starts asking questions that are maybe taking too long, you can rehearse in advance, right? I will get back to that point, but I'd like to get to this more important issue in the future. Okay, so take control of the OP stage and just be accommodating, but mentally prepared to keep things on track. Okay, that's just general advice for any kind of major presentation where you only have a limited amount of time to get your thoughts across. Okay. Of course, you get interrupted a lot during the OP. You probably heard that. And you have to ask questions that are maybe off on a tangent. But right, when it comes to something that is not going anywhere, right, try to return back to an important direction. You need to be able to present the kernel of your idea, right, as early as possible. Okay. The last part is just to make sure that you realize that this is all worth it, right? So when you graduate, right, and you're doing that PhD level job, right, with 6 figures, we hope, you're going to be asked to write a lot of proposals and make presentations. And the OP is really just a starting point. You're going to be doing this time and time again. And so, right, this is really just the practice, right? You'll get better with practice and feedback. And that's really the job of the OP thesis committee. We want to give you feedback on things that you do well, things that will need work, right? Maybe some ideas that really need to be, they're too rough and need to be polished, right? So that's our job. Okay, and I'll stop here.
So yeah, if you guys have any questions for Dr. Wei, please raise your hands, let us know.
Okay, great.
I'll repeat some of the same because, well, the requirements are very similar. So I prepared 2 slides only. The first is a brief summary of what is expected for the Pecan division OP. I'm not saying much about the research summary. That's the first slide. And the second slide is some preparation tips that overlap quite a bit with the previous 2. Okay, so let's begin with what's expected. With a caveat. First, the specific expectations can vary quite a bit among faculty. And for example, to give you an example, in our PChem divisions, I know there are some faculty who prefer that you propose something that's very unrelated to your research project, and others prefer that is somewhat related to your research project, but not necessarily, but not exactly the same, of course, and somewhat related. I like the phrasing here in the document that you will get, that it should not be directly related to your current research. Okay. But then that's where the 1-pager is really useful. So when you write your 1-pager, if there's some overlap with your research, say where the overlap is and how it's not similar. And that way your committee members can tell you, give you feedback if they think it's too related or not related enough. And Okay, so that variability, what can we do? That's how things are. By the way, it's the same thing that happens when you submit a proposal to the NSF or the DOE. You don't know who is going to be reading your proposal. You can get lucky or unlucky, and so you need to be prepared for different scenarios. And then the second caveat here is that, well, the general expectations are the same for all. The OP should be original, interesting, and generally correct. You need to strive for perfection because that won't happen. But generally correct. Okay. From the written document and the oral presentation, it should be clear that you have studied well an area not directly linked to your PhD project. Again, it doesn't have to be completely separated from it. And your one-pager should make that clear. And that you can clearly identify and state one concrete problem that you are proposing to solve. Attempting to solve more than one problem in the OP may not be the best idea. One is difficult enough. So just make sure that you choose one concrete problem. I know in the biochemistry division, you go maybe sometimes for 2 or 3, but we like one. Okay. And 2, that you have studied and understood the fundamental Pecan principles that provide appropriate background and context for your proposal. So you've already passed by then the foundational course. And as Dr. Wei mentioned, it may be a good opportunity to review some of those. So if you're talking about, I don't know, entropy, be ready to someone in the committee asking, what do you mean by entropy? So define the basics, right? So it will be a little bit like an exam in that sense. If you say a word, or you need to be prepared to explain what that means. Any question about this slide or?
So if I elaborate some concept in the written part,
Yes.
do I still expect the faculties will ask question on an oral part also?
Yes, because it's possible that the faculty did not understand perfectly what you wrote or did not agree.
Okay.
So, anything that you write, you should be also prepared to defend, not necessarily explain, but you need to be ready to defend it.
So I will expect the oral part to be an independent thing of it.
Say it again.
I'll expect the oral exam will be like independent stuff.
Yes, independent, right? It should be you're presenting what you.
So it's not relying on the written.
That's right. Yes. Mhm. Okay. Any other? Oh, and there's number 3. You have given some serious thought to how you would attempt to solve or approach the problem and what the main challenges are. Right. It should not be that the first question from the committee throws you off, and so it should be clear that you've thought about this quite seriously. Okay, so here are some preparation tips, and again, there is some overlap with the previous ones. To make it interesting, you need to be interested. It's very difficult to make others interested in something when you are not. I guess it's possible in principle, but difficult. And try to convey your excitement to the committee. That's always good when there's a good atmosphere in that room because people are excited about the project. And this parenthesis is interesting here. I try to pin down why you find the topic interesting, right? So sometimes you find it interesting just because, and it's hard to say why you find it interesting, but maybe there's something there. So if you try to go to the bottom of to the heart of it, why is it interesting to you? and that could give you a good clue to how to explain it and how to convey that interest to the committee. I think I already said this. Be ready to explain the meaning of every word, plot, what's in the y-axis, what's in the x-axis. That happens sometimes that you know exactly what's being plotted, and that's a problem. Or comments from your written document and slides. And so for that, this is I think it's a good piece of advice. If something is not necessary to make your point, just don't include it in your slides, because people in the committee can get distracted by something that's not important. And then they ask about that, everything can be derailed for something that could have been avoided if you had simply not include unnecessary information. And both Dr. Bart and Dr. Wei stressed also this one. When practicing, put yourself in the shoes of someone who's listening to you, your presentation for the first time. And you'll want to know whether the speaker, that's you, has a clear proposal in mind. Ask yourself whether, and here I'm imagining you're preparing on your own in front of a mirror, but I really like the suggestion from Susanna, from Alex, to call a group of friends and practice in front of them. They can tell you. If you know the meaning of everything you're showing on your slides and you're striving for clarity. The committee will be a little bit impatient to know what your main point is and why it's interesting and important. So you don't have to do this, but I personally like it when students do this. And I know others also like it. I have one slide that clearly states the problem that you're proposing to solve and why. And that way you start with that and everyone is on the same page and it's easier to follow. Finally, you may have chosen a topic that no one in the room knows much about. And that's fine, but it raises special challenges. And Dr. Wei had this nice plot if you were here. Do you remember on the y-axis? What was it on the y-axis? Was
Difficulty of question.
difficulty of the question, and on the x-axis you had
An overlap of research.
overlap with your current. So if there's no overlap with your research, then the questions will tend to be more general, maybe go to the core and probing the overall logic. But if it's too close to your research or identical to your research, then the questions will be, as he called them, more picky, I think. Picky is what he said. It's not a problem to make a few mistakes or to say a few things that are incorrect. In fact, it's kind of expected. The problem is to not recognize this and try to mask misunderstanding with confusion. And maybe you'll manage to confuse one of the committee members, but you won't manage to confuse them all. And, oh, no, I think that was my last point. You have question.
So we have a few minutes for questions if anyone has any questions for Dr. Wasserman. You guys can ask anything, don't be afraid.
It should be fine. It's a good opportunity also to study something that interests you, that maybe you've been meaning to study, but you haven't had the chance. So you can spend some good time to do that. And as Suzanne said before, you might even find yourself using this in the future for a real proposal or an application to fellowship or something like that. Okay, thank you.
Evangeline Lyon, and I am representing biochemistry and I think maybe chemical biology. So if I tell you something wrong, Dr. Parkinson can chime in. So this is your OP help session for BCB students. And historically, we've been kind of the only ones that have like set guidelines. You're free to direct all questions to Brian, but you can also email me. So he covered this last year. So we're just going to dive in, and please stop me along the way if you have questions. I did poll my group before I came down here to see if they had any specific advice or suggestions that they wanted me to share. So first of all, it is a good time to start thinking about planning your proposal. So your plan should be hypothesis driven. It should not be, I'm going to screen 50,000 molecules and I'm going to find one, and that one molecule is going to cure a disease. No, definitely not. You want something that you can ask a question about. Like, I think that this protein is going to interact with this other protein for these reasons. And then I'm going to test that interaction in these ways. And if this is a real interaction, then these are the different outputs I would expect to see. So ask a question, have an answer in mind, and then how you're going to test things as you go to that answer. And it's totally fine if your hypothesis ends up wrong. So as you think about this, you want to have a topic that is novel. This does not mean to find one paper in a sketchy journal and be like, this is it. This is a great idea. No one's looked at this. There's probably a reason. You want to find a topic that you are interested in that is novel, at least novel to you, and take it a step farther. So, for example, if you find a study that used a mouse protein, saying that you're going to repeat the experiments in a human protein, no, that is not novel enough. You need to take it a step beyond that. This also does not mean, though, that you need to take it to the extreme, that you are going to pioneer a new method that's never been tested. So you want to find that middle ground. If this is an interesting question, these are some things, these are some other questions I could ask that are related to the topic, and then how I would test those. I tell my group that a great place to get started, if you're totally lost, the last paragraph of the discussion section. Because that's where the authors are going to go off on their favorite pet theories that they have no data for, but they're really excited about. And so there, they are making hypotheses based on what they know, and that can be an idea for how you think about developing your own project. You want it to be something significant. Again, please don't tell us that you're going to cure a disease. You know, it would be great if we could, but we all know that's not feasible. But you do want to make it something important. That does not mean it has to be health relevant. That's something that a lot of people get tripped up on. It's like, it's not disease focused. It's not applicable to human health. It doesn't have to be. It just needs to be an important problem that you care about. And it can be something that you can also convince us is significant. There's a lot of things that are outside our area that we might not know a ton about, but then you read more about it. You're telling us why it's significant, and that's absolutely fine. Part of learning how to do this OP style or writing fellowship proposals is convincing someone of the significance and importance of the problem. You also want it to be feasible. This does not mean that you have 50 years, an army of postdocs, and every imaginable piece of equipment or reagent in the world. You should be able to do the experiments that you're proposing in a couple years, assuming that you have standard equipment or techniques or reagents in the field. You do not actually have to do this, right? This is not something that you're going to actually do in the lab, but proposing a NIH 5-year, fellowship or grant that's driven by an entire lab, no. This is one person's project. Doesn't mean you can't be ambitious, but it needs to be work that one person could feasibly accomplish. And so as you go through and start to organize your actual document, you want to think about, why is the work important? Why should anyone care about this topic that you've chosen? And that's one of the most important things. If you can't sell the significance or importance of it in the first slide or two, it's going to be really hard. You also want to know what has already been done. So what is the state of knowledge in the field? Is this just one paper that one lab published this one time? Or are there 2 or 3 labs that have worked in this area for a couple years, and there seems to be maybe they might have competing hypotheses. Maybe there's a big unanswered question that they just haven't looked at because they're also focused on their own things. But something that you can tie into the greater body of literature. So it doesn't need to have thousands of papers associated with it, but you don't want the one-off, right? That's going to be a hard foundation to build on. This also, I'm just going to touch on this here, but we can talk about it more too. One thing that happens to pretty much there's one person every year that this happens to. They get scooped, right? Their proposal that they've worked for months on, there's a paper that comes out that upon first reading is identical to what they proposed. That is not your fault, okay? That is not a case to panic. One thing is that very rarely, not to say that it never happens, but rarely has your entire idea been scooped. They might have gotten part of it. Depending on how close it is to your exam date, there are different things that can happen. You know, if you're 3 or 4 months away, you can address that problem, right? You can come up, you can spin your own work in a way that's different enough. If it's the week before, no committee is going to be like, oh, well, I guess you got to start over and write a new proposal on a new topic in a week. No, this is just something that happens in life. And if nothing else, you can try and convince yourself that's actually a compliment. And this is something that I have tried to do with borderline success, that, hey, my idea was so good, other people actually did it. Right? So there you go. You can pat yourself on the back, but do not panic about it. It is, again, this happens to one person at least every single round. So just talk to your committee chair. What are you going to do? You know, what are the questions you're asking? What are the experiments you're going to do to answer that question? And then if they are novel, so maybe it's a new technique, maybe it's a new way of applying a technique, what makes it different? Novel can also mean, what is the intellectual contribution? It's really easy to get bogged down in like, I have to invent something. I have to apply a new method. Sometimes the methods that we use in our labs are the best methods available. So why would you not use the best method available? In that case, you can explain why what you're doing is conceptually novel. Like, you're taking these established tools and you're answering a new question with them. And it's only with the tools that you have that you can answer this particular question. And then finally, how are you going to do the work? And we'll talk more about this. You actually need to think about what experiments you're going to do, how you're going to do them. And I'm just going to note now, and again, this is something we can talk about, the words that you choose to describe these experiments matter a lot. So if you are if you're proposing an experiment, for example, using cells, what type of cells? How are you going to put the DNA in? Is it a transfection? Is it a transduction? Is it transgenic? All of those mean very, very specific things. They are not interchangeable terms. If you're not sure, one, you can just Google it, because Google will get those right. And also, another good place to look is other papers. If they're all using the same terminology, there's a reason for it. That's something that we've seen prop up a lot more in recent years, is what exactly words you're choosing in terms of describing a scientific experiment. Okay, so for our proposals in BCB, we want you to write an NIH style proposal. There's a couple reasons for this. One, there are so many examples available online. And specifically, we want you to do an R21 format that is not 12 pages. Not 12 pages. It is 6 pages. You have 2 font choices, Arial or Helvetica. That's it. You have 11-point font or larger. You cannot go smaller except on figure captions. That's the one exception. They can be 9-point font. You can also get 1-inch margins. That's it. So all of your text, all of your figures, all of your methods, all of your figure captions have to fit in that 6 pages. That does not include references. That is totally separate. For NIH, you also have a separate document that does not count towards the 6-page total, that is called the specific aims page. This is a 1-page overview that covers your entire grant. So oftentimes, this is something that you write at the beginning, Then you go start writing your proposal. As you design the experiments, you realize that your specific aims are all wrong and not what you wanted, and you go back and forth. But this is not an abstract. This is an overview of what the question is. So what is the question you're trying to answer? What's the unmet need? What are you going to learn from this, assuming your hypothesis is right? And it is okay to write your proposal that your hypothesis is correct. That this is the question you're going to answer, this is what you think is going to happen, and this is how you're going to test it. You're going to talk about what those results you expect them to be, what is the most likely outcome, and then how is it going to be impactful? Again, it does not need to change the world. It can also be a very vague, like, if this is successful, it will facilitate the development of new pharmaceuticals to treat something. Okay? So you're thinking about the future, but you're not saying that you're going to cure disease. You need to do the basic research first. You need to have two specific aims. Those are two independent scientific questions that you want to answer. This independent idea also has been a source of confusion in that they can be on the same topic. They don't have to be like totally unrelated. It could be, I'm going to work on this particular protein by itself because I think it's doing this one thing. And then my second aim, I'm going to also look at its role in this particular pathway because I know it's in this pathway and we don't really know the details. And a good check for yourself is, could you do both of the aims at the same time? Right? Can you do both sets of experiments in parallel and learn from what happens in one aim versus the other, but not have, I can only do this experiment if everything else works right. That's a bad situation to be in. You do not want that. But if you can do them at the same time, that's a good check that they are independent. Yes.
For the aims,
Uh-huh.
if there are aims one and two,
Yes.
we do aim one as in vitro, or do the aim two as in
Okay. No, that would not be considered dependent. And a lot of it will also depend on, as you write it, like, does it make sense you could have these two arms of research going at the same time? But that's a pretty common strategy is one aim is totally in vitro, one aim is more cell-based or in vivo. You can come in. You can have three aims. There's this idea that you need three aims to be successful. No, it is better to have two good ideas than two pretty good ideas and one that's just like way out there. Okay, so play to your strengths. Aim one is always the aim that everyone feels most confident in. And that's also how we write grants in real life. Aim one is your favorite idea that you put all the effort in. Aim two is like, okay, this is pretty good. Aim three is like, maybe. So the aims page is a standalone document. I should be able to read your specific aims page and have a good idea of what you're doing, how you're going to do it, and what the results are going to be.
The other six will be like elaborate.
Yes, the other 6 pages are the details. Some people will put a figure on their specific aims page. You do not have to. It's whatever you feel makes that page more readable. Questions so far?
So in this case, each aim should be like paragraph of 6 to 7 sentences.
They're usually a lot shorter than that. So most of the specific aims page, I would say like 2/3 of it is, this is the problem. This is a little bit about what we know about it. And this is my hypothesis. And then I'm going to test my hypothesis in these 2 aims. And then like the last 2 or 3 sentences are like, and then I'm going to change the world.
I have a book outside of my office that is NIH grants, like how to write them. And they have kind of a whole chapter on how to write a specific aims page. So that'll be outside around 4103E for the foreseeable next few months. No one is allowed to take it out of that.
But you can look at
it. You can look at it and you can photocopy it. There's a photocopier in that room, so feel free.
You can also look at examples, right? You have lab mates that have passed their OP. Go ask them what they did. You can look it up online. There's lots of great examples of how to write them, what not to write, all of that. And honestly, the specific aims page, I think, is the hardest part of the grant to write because it is supposed to be this whole all-encompassing thing. And it's much easier to write about how I'm going to purify a protein than to provide you with this big background of why you should care and all the broad strokes that you're going to do. So it's okay if this gets done last. Like there's not an order you have to do these things in. So this due in August prior to the OP, this is that white page that got added into the annual reports for second years, and it's just pitch your idea to us. It does not have to be the final specific aims page. It's just like, this is what I'm thinking about. These are maybe some of the experiments I want to do. Is this a train wreck or is this solid? That's it. It's a go, no go decision. And the reason we added this in is because a lot of students, or not a lot, enough students were picking topics that were really hard to defect. And we didn't have an opportunity to give that much feedback before. And we don't want you to spend your time chasing something that's not going to be defensible. We want to make sure that you have a solid foundation to start writing this from. So the idea is that it's helpful, not an extra burden. And I think this is the second or third year that we've done it, and second year. And I think overall it's been helpful. But if you have suggestions for how to improve it, please let us know. Okay, so another way that you can start to break this down. So this idea of structuring your specific aims, you've got an opening sentence. This is usually like, according to some big health organization, if we don't fix this problem, X millions of people will die unless we fix this thing. And then this is how I write my grants. Okay. And then we go into, this is what we know about them. These are all the things we don't know, but hey, this is what we are really good at doing. And these are the ways that we can start to answer these questions. If you don't let us do these things, then we're never going to be able to go back and fix this disease that's killing all these millions of people, and we'll never be able to answer these questions. And then you go into, okay, our long-term goal, or my long-term goal for this project, is to do something. And in this application, which is not going to be your whole career, but in this specific application, so the next 3 years of my life, I'm going to spend answering this other related question, like a sub-question, and it's this. And then I'm going to go into the things I'm going to do to answer it. So this is my question 1. This is what we're going to learn from it. Question 2, what we're going to learn from it. And if you give me the money, this is how I will have saved all these millions of people, closed these gaps, and set us up for this long-term success. So it's all sort of self-reinforcing that this is the big problem. This is the gap. I am going to start answering that gap with these experiments, and then I'm going to save everyone from this disease. Again, it doesn't have to be disease. It's just that's often kind of where a lot of BCB research is geared. So it's in a little bit easier framework to follow. And if you want copies of this, you can let me know and I will send it to you.
We will also be sending out these slides.
Okay. All right. Questions on that? Again, I think the aims is the hardest part because, again, it's forcing you to step way back and write it for people who have absolutely no idea why they should care about your project.
Supposed to be in 6 pages.
This is 1 page. 1 page. Yep. And then you're going to dive into the details and the rest of it. And that's called the strategy. I have to start. Okay. I have to talk faster. All right. Strategy is the part that you're all imagining is most of the grant, but really is not that much of it. The strategy is what you're going to do and how you're going to do it. So background and significance. Why does this problem matter? How are you going to fix it? Can be about a page, maybe half a page, depends on how much is known about it. If it's Alzheimer's disease, we all know what that is. You don't have to spend a ton of time talking about it. Innovation. So did you invent something for this? Are you contributing something new? Ideas count, okay? Do not discount adding something to the field that is just knowledge-based. That's really important, especially now. The approach is where you should spend most of the time talking about what your experiments are, right? So you have your specific aim, so your big question, and then you can usually break that down into like 2 or 3 smaller questions. Those are your sub-aims, and that's where you're going to get into the details of your experiment. I'm going to do this cell-based kinase assay to test this function under these conditions, and this is what I think that data will look like. I think it is much easier, and I feel confident speaking for BCB on this, show example data. Please show example data. It can be something you draw. It can be something that you find online that looks like your results. It will make everyone's life easier, especially if you do something like a Western blot. Do not describe your Western blot to me. Please do not. Just show me a picture. And that's also a lot easier to explain because you're going to have to present this. So that way you just show a picture. Hey, I expect to see something here. These are my controls. I see these controls and so on. So when you propose your experiments, you want to describe what you are doing, why you are doing it, why you chose that method, and why it is the best method. You also have a potential problem section. So you have to acknowledge the fact that everything can go off the rails. So if your hypothesis is wrong, if your experiment does not prove it, what will you learn? And you can always learn something even if it all goes wrong. Okay, and then your thesis research checkpoint. We do not expect a blow-by-blow breakdown of your whole project. We want to know what you're doing and why. What's your project? Why are you working on? How'd you pick it? What techniques are you using? And oftentimes we know what lab you're in. We have a good idea of what you're going to be doing. But if you're doing something different or more niche, let us know. If you've got example data, awesome. If you have a bunch of data that shows everything that hasn't worked so far, totally fine. That's very common in a BCB lab. And then finally, what are you going to do in the future? What are you going to get done in the next year or the next 2 years? And then just super quickly, these are just some big points. Don't cure a disease. Don't take an incremental step forward. Ask for help. This is probably the biggest thing. Your peers are way meaner than your committee will ever be. They will ask you more evil questions than any of us could ever think of. So please take advantage of them. And everything in your proposal, every single thing that you put on a slide is fair game. If you don't want us to ask a question about it, don't put it on the slide. You can either make your own or put white boxes on stuff. It will drive your lab nuts, or your peers nuts, but it's a good way to have a figure that only shows what you want. Backup slides, totally allowed. You can have as many as you want. If you have questions, you can email me or Brian, whose name is on all the slides. I'm sure he'll be delighted, but we are happy to help. And you can ask anyone for help except your advisor. They should be dead to you for this.
My work, how many lab pages has to be to explain my work?
Oh, for the research part, it's usually 10 to 15 minutes. We know you're tired. The idea is that it kind of ends on a high note because it's something that you know really well. And the closer your project is to your thesis research, the more background we expect you to know.
This research work should be included in the presentation?
Yes. It will be, yes, it's totally separate.
All right, let's thank Dr. Lyon again. And let's invite Dr. Parkinson for the organic section.
All right, so I know that some of the organic people kind of caught the last end of the BCB section, and there is some overlap. So I will try and be kind of succinct with some of that. But as far as thinking about what topic you want to do, first and foremost, make sure it's something that's interesting to you. You're going to be working on this for months. Don't choose something that is boring. Again, you want it to be distinct from what you are currently doing. The closer it is to work that you are doing in your lab, the harsher we're going to be when we question. So I'm not saying go off and do something like PChem if you're organic. Don't do that. That's not what I'm saying. But if you are working on nickel-based catalysis, maybe don't choose nickel-based catalysis for your opinion. Just say. As far as where to come up with ideas, I really like reviews because oftentimes the last couple of paragraphs of a review says what's kind of the future directions of the field or where there are gaps in the field. Also, the last paragraph of a lot of papers also. I have some common topics that organic students oftentimes like to do. So total synthesis of the natural product, synthetic methodology, chemical biology or chemical tool development is also great. You do not want to say you're curing a disease. I don't care if you're synthesizing the best natural product in the world. You're not curing a disease. You are developing routes to chemical tools or to potential leads. You can also, obviously, another area that people do a lot is different types of functional materials. If there's something you want to do that's not on that list, That's fine. This is just what we commonly see. Your proposal, though, needs to be hypothesis driven. Please do not tell me that you are going to do a high throughput screen and find the best thing ever, because that is the easiest thing to poke holes in. Well, what if you don't find something? Project over. Probably not a successful. That said, there's a lot of different ways to make it hypothesis driven. And so you just want to make sure that you are not depending on random chance for this to work. Now, if you want to design an inhibitor of an active site, that's great. Don't say that you're going to screen an enzyme against this 100 million compound library. Now, if you want to do a virtual screen and find something that way and then propose derivatives, that's fine. But then you actually have to screen, and a lot of times. Again, we already mentioned this, but something distinct from your research, talk to other people. So you should be starting to read and think about this now. Talk to your lab mates. You can talk to postdocs in your lab. You can talk to other professors, as long as it is not your research advisor. So you can talk to your committee members. You can talk to other professors who aren't on your committee. So talk to people about these ideas. I like to have like a separate, like either notebook or folder where I just type all my random ideas as I'm reading literature throughout the week. And if you see something, go type it in and you can go back to it later. All right. As far as the actual writing of the proposal goes, we suggest that this be either an NIH R21 format or an NSF grant format. What I will say is that there are examples that can be found here. I also have 2 workbooks that I'm going to put outside my office, outside of Brown 4103, where it shows you examples of how to write these. Now, there are specific sections that I want to talk about briefly. In general, you don't want to be going over 8 pages. It is not helpful to go over 8 pages. Generally, I say about 6 is usually good, including your figures, tables. Please include figures. Don't just have blocks of text. I suggest having at least 1 figure on every page. That will help you to kind of keep track of what the biggest things are. These figures can be like workflows. They can be chem draws of how you make things. They can be example data. If you do example data, make sure you label it example data so that we don't think it's real. In general, we suggest Arial or Helvetica, size 11 font or larger for the actual text, and figure legends being at least 9. This is so that we can read it. Remember, your committee members are old. We don't have great eyesight. So you know the quickest way to annoy us? Make us squint. They were like, nope, we're done with this. So make it easy to read. That said, make sure you have subsections. So don't just write blocks of text. You're going to have an introduction background section. You're going to have a significance or innovation section. That might be my next slide. Yes. So an innovation section. So in that innovation section, you're going to say, why is this thing you're doing innovative? Cool. That could be if you're doing a new methodology, why is yours different from what everyone else is? For your background and significance, why do we care? If you can't tell us why we care, that's a real bad sign. So you should be able to say why in the world you care about what you're writing about. And this is another thing, if it's not interesting to you, you probably don't care about it, and you really can't convince us. So, and then the other section is the approach and experimental methods. What are you actually doing? What techniques are you going to use? For this, your approach, you should be able to do this in 2 to 3 years. This is not a whole career worth of work. This is 2 to 3 years that a single person could do. People have asked me in the past, do I need to worry about budgets? No, we don't care about budgets. Pretend like you have all the money you want. Luckily. The other thing that I want to point out is a specific aims page. This is that one pager that you have to turn in August. A specific aims page kind of is a mini description of everything you're doing. And so you have a paragraph of like, why do we care? A little bit about what's the gap. So there's something missing and it needs to be filled. Oh, guess what? I have a great idea on how to answer this gap. And these are how we're going to do it. And last of all, if we're successful in that, guess what? We solved that problem that I mentioned, that gap. Now, this is one page, and it's an overview of your aims. You usually have 2 or 3. I would highly suggest have 2 aims. You'd rather have 2 good aims than 3 aims. And they should not be dependent on one another. Your first aim should not be, I'm going to synthesize this natural product, and your second aim being, I'm going to do biological testing. Because what if that first one doesn't? You should be able to do both aims at the same time. Start early. You want people to read this. It doesn't have to be perfect when you give it to people to read. But you need to give people time to read it. And then you still need time in order to revise it. And this is a terrible little comic. You do not want to be impenetrable fog. Remember, you want others to understand what you're writing. And sometimes it's hard to tell. One thing that I found is if you read it out loud, if you can't read a sentence in a single breath, right? So read it out loud. That oftentimes will tell you where things aren't clear. As far as your presentation goes, it should be around 20 to 30 minutes. You will be interrupted. Full stop. Now, what I would say, this 20 to 30 minutes is for your OP presentation. Then have about 10 minutes for your actual research presentation after that, is what I would suggest. Now, for your OP presentation, minimize the background slides. Only tell us what we have to know for us to understand your proposal. This is for a couple of reasons. One, the major one is that if you do a whole lot of background, we're going to start poking you on it. Everything that's on the slide, you should know. If you show a graph of them doing something, you should know how they did it, because we will ask you about it. Whatever is on that slide, you're like, oh, I don't want to talk about that. I can guarantee you that's what we're going to ask a question about. Again, focus most of the slides on your actual proposal. A content thing, generally you don't want a whole lot of text. This is a terrible slide. Do not do this. Generally, a little bit of text with more figures, images, pin draws. Have backup slides. Especially if you're proposing, I know I talk a lot about natural products, just where my brain is. You're proposing this cool synthesis of a natural product, and there's this key step that has a really complicated mechanism. We're going to ask you about it. I have a backup slide for it. That way you don't have to draw it all. And if needed, please include controls. This is particularly important if you're doing biological experiments, but also, for example, if you're proposing a mechanism of an organometallic reaction and you think the base is important, probably want to talk about the base, how you're going to control for that. Again, for practice, please practice. You're going to probably want to practice more than once. Practice with your group. If you have friends that are going through this process, practice with your friends. They're likely going to be meaner than we are. Tell them who's on your committee, because certain committee members have certain reputations. I'm not going to tell you what those are. I think you all know that. And if you don't know that, talk to your friends. I think that's pretty much what I have. Are there questions? I kind of don't believe y'all don't have questions. If you think of something, gosh, I wish I'd asked that. Feel free to email me. I'm happy to answer questions. I'm happy to meet up briefly. I can't meet with you for an hour and talk about everything on your proposal, but if you want to have a quick meeting, I'm happy to do that. You're gonna be okay. This is hard. It's supposed to be hard. But you're gonna be okay. Just start early. Don't wait to the last minute and talk. Those are the biggest things. Okay, cool. Definitely reach out if you have questions.
All right, let's thank Dr. Parkinson and welcome Dr. Zhang for.
All right. All right. Okay. Good afternoon, everybody. So, on behalf of our divisions, I want to give you some introduction of the OP requirements and also answer any questions you might have. So basically, oh, by the way, these slides are prepared by Dr. Laskin. So I think they're very good. So I didn't make any changes. I will just follow this follow the flow here and then make add anything I think I needed. So basically, you wanted to think about the okay, why we're doing OP, right? So what is the role of OP? Basically, is assessment of your really qualified of continuing pursuing this a PhD study or not. So that is the first thing you always want to ask the question. So what am I doing the PhD and is this the right path for me? And many of you may think, of course, why otherwise why I'm here? But it's actually not the case because sometimes during this first 2 years, you might think this is not something I like, and then that's actually I mean you'd better make a different move earlier because. If you're working with if you want to get a PhD, if you want to work as a PhD, you're gonna have the duties in the future, career as a PhD, and that is actually become independent and become critical thinking experts and that's actually what the OP is assessing. So if you think this is not something I wanted to do in the future, and maybe PhD is not a good way for you, it's not a good degree for you. So okay, so OP is basically original proposal. Basically, you're assuming that you're proposing something. Let's assume that you're proposing this to a funding agency to try to get money, right? So that's what you will do if you're in an independent, either a research scientist or in some company or a PI or some national labs. You want to propose something to get the money so that then you can support the other people that work for you. So then this is actually how to propose. Okay, how to propose them? Okay, you have to basically demonstrate that you're an independent scientist when learning a new field. Okay, so first of all, you have to demonstrate that you're independent. Basically, this OP idea is created by yourself. It's not by working with an advisor, working with anybody else. So at least in our division, analytical division. So I know some stories from other divisions that try to kind of connect more of the OP with their research. So at least in our division, we still look for the original ideas from yourself, not just something that followed by I mean, where your research has been what you have been working on in the past like 2 or 3 years in the lab. So we of course we still have that session, but that's it's a different part. So we first of all want to talk about this major OP part. So okay, you wanted to demonstrate that you're independent. You create this idea yourself and you critically evaluate the status of the field and you're interested. And of course, I think the previous speaker, Bessie Parkinson, raised a very good point. You have to find this subject interested. You're interested in it, right? Don't find something that you think is it's not it's kind of it's okay. So you want to have passion in it. So then once you have the passion, then you actually wanted to look into it every day and then prepare for it. So I can work an idea through the end. Of course, you have to work through the entire idea and the entire proposals. Are able to communicate their idea both orally and writing. Now, basically, orally is your oral exam, writing is your writing proposal you submit it to your committee members. So that's the basic things. And then keep in mind that you're evaluating by a friendly group of scientists who want to learn from you, not just to try to give you a hard time. So the committee members you can talk to, not your advisor, but your committee. Usually, you can communicate with your committee members to get some ideas of is your proposal or your rough idea, is it reasonable or not? Is this too close, or is this like a uh, um, novel enough? So you can communicate with your friends, with your committee members as well, but not your PI. So passing rate is high. So, but you need to take it seriously. So the passing rate is indeed high. So most people pass. But uh, if you think this, you don't like to do OP, you don't like to being able to, I mean, to put in the position of doing this thing all the time in the future, and then you're probably thinking about a different path instead of continuing the PhD. So that's so most of the questions will be driven by the desire to understand your ideas, not to test you. So well, that certainly makes sense because we're trying to learn something from you, not just to give you a hard time. So and make sure you understand all the aspects of your idea. So everything you put on the slides or put into the proposal is fine because people won't ask you questions. I mean, they might remember to ask you the question during the OPR exam, but most of the time they just look at your slides. The committee member look at your slides and basically can stop you anytime. So if you put something there you do not know what it is, or you do not have a thorough understanding, you probably will have a hard time when you try to get and when you were asked to explain it. So yeah, that's actually important. I think that's why it's highlighted. So you should be able to defend everything that you're proposing. I would say mostly everything. So not maybe you will have some you forget something and you ask it, you run into a question you haven't prepared. So those are fine, but at least you're during the oral exam you're thinking along the way that to solve this problem, not really answering that all the questions, but at least you can have a reasonable thinking towards finding the answer. It will be all right. So, and the advantage and limitations of all the techniques and the approaches that, including those you mentioned in the introduction. So basically, that's basically saying that you wanted to have a thorough understanding and be careful of what you put into the slides and make sure you don't put too much. Okay, so put some. The more you put there, the more risky because the more you put there, you're gonna probably get point to the direction that you're not really looking to that carefully. All right, where to start? So you can find some recent review articles, read more. So that's always the case, right? So if you read broadly, and then you can always find something that you think that might interest you. So, but I would say stay relatively far away from, but not too far. It doesn't have to be too far, right? You don't have to. Let's say you're doing mass spectrometry. You don't have to look into something very far away, like measuring some rocks using spectroscopy on the moon or something. It can be related, but it doesn't have to be very far. So, but the thing is, if your novelty is relatively low, so some people I saw that they put some like basically using all this existing technologies just to measure something that nobody has measured before. That's considered to be relatively no novelty because you didn't put any new methodology because we're analytical chemistry. We wanted to develop some new tools or new methodology to do some measurement science, right? So if you're just using whatever available in the lab and do some measurement of some samples that nobody has measured before, it's considered to be the relatively no novelty. If it's low novelty, then people will have your committee member will have high expectations on how much you know this field. If you have a relatively high novelty, if you develop something that's completely new, and then you're probably have more freedom or room of justifying it. Okay, so of course you're analytical chemistry, so focus on chemistry. I've seen people not really focusing on chemistry; they focus more on the physics. So that makes it a little hard to justify because I mean at least you should have some kind of chemistry components in the proposal to for chemistry OP, right? All right, so okay, then that's basically the summary of I think find the topic that interests you through broad reading, propose a solution, and how to balance your novelty and your and also how to find the direction. So and this is the written part. Written proposal is structure is tentative, so it's not really there's no fixed form of it, but you can. I think this will be shared by shared, right? So okay, so I think you will have it, so you don't have to take a photo. So of course you need to have a title. So do not make it too technical, relatively broad. And then objectives, usually a few sentences, basically just a quick overview of what this your proposals is about. And then the background and significance. This part is actually very important. So basically, you can see here are some questions. What is known? Why this is significant? So what is the gap? What do they still? Why do they still exist? And what is the key questions to address? Key questions or proposal trying to address. So these are basically the questions you probably during this preparing this you can go through it over and over again. So and basically, if you wanted to propose something, try to get money from a funding agency, right? So they want to ask you why this is important, why they give money to you to do this. So what is the significance of it? That's usually the bigger picture. A lot of people focus on technical part. I've seen a lot of OPs, most of the OPs actually, especially analytical chemistry OPs, focus on the technical part. They started to see, oh, this whatever technique has can measure this sensitivity, and I can measure maybe like a little bit better, or I can improve something a little bit better. But that's not the significance. The significance is your broader picture, right? So why overall this improving this technology to a better resolution, to a better like a sensitivity is going to help to address whatever question that's going to benefit the overall the larger scientific field or the humanity. So okay, so then what is known? So that's the background search. So you want to search the all through these literature reviews and find what has been done already. So you might run into the cycles of create an idea and then go back and search and see what's been done. As you found that it's already been done because people are smart. They already created this, and then you say, "Oh, okay, it's not going to work. I'm going to do it again." So you do it again and again until you find something that nobody have no it has not been done by anybody, and it's you created it. So that is critical. So and basically this is basically your research. So when you enter when you join the lab, right, when you started the PhD study, so you have some projects given by your advisor, and they probably already did this for you. They know what is the gap, what is unknown, and you basically just work on it on the technical part. And this whole OP process is to help you train you think as a PI, so that you're creating a project yourself and make it viable. So that's why this background and significance usually most people ignore it or put very little emphasis on this. So and then why these gaps still exist? Okay, what is the gap? Let's say if you can measure something uh, that is moving very fast, for example, and then nobody can measure it. So why nobody can measure it, and why the way you think of it can measure it very fast, and people only measure the like you have to be um, in a fixed sample or a stationary state. So what is the key questions your proposal aims to address? Okay, well then that goes to the basically connect to the next one, the specific aims. So usually in the proposal, if you find some proposal from an advisor or from other people, you'll see that you have one or two specific aims. So you can two or three. So I've seen people doing two or people also doing three. So you can make sure that if you have two, then each one is more thorough, and if you have three, then you will make sure that they're not just like loosely connected. So something like that. So basically, identify and briefly describe two or three. I think I would say two or three. So specific aims of your project. It is best if these are parallel, because if they are sequential, if the first one doesn't work, if your committee asks you questions and turn out that the first one doesn't work, then you don't have to talk about the two and three, right? So your proposal is pretty much killed. So it's better to look into the three parallel. So that is actually a little bit tricky because parallel doesn't really mean that you have to like do one, two, three different completely different things. You can actually assess the same topic from three different angles. You know, it's let's say one aim is assessing it from let's say improving the limit of detection, and the other way is trying to improve another aspect, right? So those could be in parallel, but it's still tied together in the same topic. And the approaches describe how you will address the specific aims. And that's basically your major part of your basically extending the specific aim, two or three major aims, and each one you have your specific plans, and make sure you include figures. Don't write just all the text. Without the people will be bored if you look at the everything just text content. So you make sure you have one or two high patchy figures there, so that if people are the readers can quickly get the ideas, and also you can use them to better support your proposal. So, and of course you have a summary, so that is relatively easy. So references, put all the references in a professional format. So if possible, you can find some copies from like NSF, NIH, DoD, DOE, or any format, but they're pretty much similar. So you can find it from maybe from your lab's shared folder servers, or from your senior colleagues from your lab, from other people's proposals. Those are good references you can look into. The OP exam, the most scary part. So present it. Of course, when you write the proposal, is people won't ask you questions when they read them, but they will save all the questions. And together with the questions they found in the OP presentation, and so they will ask all of them in this like a 2 hour time. So present your original proposal. Prepare slides for about 20 to 30 minutes for present without interruptions. Okay, so okay, you prepare it for 20 to 30 minutes, assuming that there's no interruption, but I'm sure people will interrupt you. So that's why you don't prepare for 1 hour of talk. So because you will be stopped almost all the time. And again, this is the first part is basically this is your original idea part. Okay, it's not your research part. So prepare a 20 to 30 minute presentation and prepare them. Expect to be interrupted and all the time, and use figures and from literature to support your idea. Basically, I think you have been to the any of this. Either you have went through the seminars already, or have seen many professional seminar from our students, right? From invited speakers. So you know how what is a professional slide should look like, right? So you have a figure, you have a title, you have a figure, some text explaining it. So don't put the entire slide, all the text, and don't put it like a random figure there with nothing, no explanation. And if you cite somebody's paper, put the reference there. So those are basically very basic things. So I think in your group meetings, you probably will go through this again and again with your advisor and your colleagues already. So use your own calculation simulations. Do not make up data. Yeah, don't make like a bar graph, like something like just made it. So I think you can either do some calculations and or even copies from some like a reference from references, and then cite the references. It's better than just make up data. So be prepared to defend everything shown in your slides. Again, this is I already mentioned this. Make sure that whatever you put there, you can explain it. Don't put something that you have no idea about, and that will give you a hard time. So have readily accessible backup slides. So sometimes you don't want it to show everything because you might prepare a lot more. So you can put aside from this 20 to 30 minute slides. Usually, I think 20 to 30 minutes means like around 20 to 25 slides. So usually one slide per minute. That's quite reasonable. And then you can put more. You can put like a 100 backup slide if you want. So if somebody asks you a question, it's actually good because if your committee member asks you a question and then you can immediately find a backup slide for it. That means that you already studied it, right? So you're ahead of the question.
We
Yeah.
do need to start wrapping up the session.
Oh, okay.
Sorry.
All right, so you can read the rest of them. I don't need to read this yourself. Basically, okay. Well, I do want to mention that I've seen a lot of OPs actually now starting to emphasize more on your own research part. So do not downplay it. So your own research is actually important. You want to present it, and if you have some, if they ask you some questions you cannot really answer in your own research, that will make you look really bad. So that is something that I hope you put some efforts in it too. So prepare like a 15 to 20 minutes presentation for your own research work. I think, what do I have? Oh, don't and don't. Okay, I think I probably don't have much time. You can read it yourself. So basically, let's just reiterate what I just said. But I want to save the last few minutes. So if anybody has any questions. Okay, seems everybody is ready for OP. So
We do have a graduate student panel right now.
okay, all right.
All right,
All
if there are
right.
any questions, let's thank Dr. John. It's time. And we'll go ahead and get started on the graduate student panel. Now, if you want to come up, I'll try first for the rest people. What you guys say. If you guys want to just stand in a line up here. Unfortunately, I do not have chairs for you guys. There you are. It's fine. Oh, I love this one. Display your guys' faces. All right, so this is our panel of graduate students for you guys to ask any questions that you want to. So does anyone want to start? I guess we could also start with introductions of you guys. If you want to go down the line and introduce yourselves.
Hi, I'm Autumn. I'm the fourth year biochemistry student.
Hi, I'm Lisa. I'm the Pecan division in Ming-Chuan's group as a third year. I'm Lauren. I'm in Suzanne Park's group, and I'm a third year.
Yeah, I'm Mahbul and I'm also third year and I work in Krishna Gita.
Mosumi will also be here in a second. She had to run really quick to do something. But she'll be here. She's from Graham Cook's group. She is also a third year. To introduce myself, since I haven't done that yet, I'm Melissa Moore. I'm a third year in the analytical division in the Julia Laskin group. So I might hop in and give a couple comments as we're asking questions, but we'll mostly throw the questions to these guys. So does anyone have a question that they want to start with? Feel free to shout it out. Yeah. So you're asking about kind of like how close to your topic, was your research to your topic? And I think that's something we can kind of go down the line and ask everyone to kind of like get an idea across the divisions. I'll kind of speak to analytical. My topic wasn't super related to my research, so I do mass spectrometry imaging. I was doing a sort of different imaging modality as my OP topic, kind of looking at a similar class of biomolecules to something that I look at already. But in the way you kind of, I think it's a good idea to at least get away from your technique, especially if you're in like mass spectrometry. But I think like kind of getting away from the methodology that you're currently using is a good like way to kind of make sure there's at least a good enough gap between your OP topic and your research. But yeah, if you want to go down the line and talk about how close.
So for me in my group, I do a lot with small molecule synthesis. So I at least still did small molecule synthesis in my OP, but I did an in silico approach to designing a light path for targeting prions in the brain. So there was some influence from my research, but not too heavily close to my research. So kind of with organic, you kind of want to take a little bit of a step outside of your comfort zone, a little bit. You don't want to fearing your own research.
Yeah, for biochem, I think I'll echo what you said over there, that taking different techniques and methods is definitely gonna be a plus. Um, definitely don't be working with the same protein, that's obviously off limits for biochem. And in general, like, you could be maybe looking at like an off pathway or like signaling pathway or something for this protein. But if you're in doubt, at least for biochem, I imagine for all the divisions, you can ask your committee, preferably not your PI first, but usually you can ask your close and they'll tell you that time before you start, you're like 5 pages in, 2 weeks away. So.
For PChem, depending on, I will say you can talk instead of like going on your own, can like always start with chatting with the PI and your committee members to kind of get a feel of how they want it to be, because since PChem is a pretty small division, that different PIs may have different ideas on it. And because I'm doing theory, so I chose like a more computational topic because I know like delving into theory, it will take a lot of time off of my research work to do. So instead of like doing pure theory OPs, I was just looking at some of the more computational methods, and we mainly do like materials. So I looked at some like catalysis instead. So I will be still doing like DFT calculations, but the material kind of changed, right? You have to do DFT. I normally do DFT on materials. Then they pivoted to do like to propose like what methods we can do for catalysis, and you just need to like read over what is the experimental side, what catalysis do and stuff like that. And I think that can also stems from experimental side of PChem as well. You can kind of stay within the same bigger circle of your experiments, but focus on some like a different topic from what you've done. Yeah, kind of similar to that. In my lab, I do like uranium compounds and making uranium and neptunium or compounds from those elements. And then my ligands that I usually use are nitrogen, so like nitrogen, phosphorus, arsenic, stuff like that. And I just use them as like ancillary ligands. But my OP was focused on the actual elements, phosphorus, arsenic, and stibine itself. So it was kind of like there was a bit of overlap in the sense that I was using the same elements, but not in the same way that I was like using them in the same way. Like they're the focus of my OP topic. So yeah, I think when you go up to do your like 1-pager report that they're having you do now, like that's a really great way to make sure that you're on topic and basically like you're not straying away from a topic that's like wildly out of your scope or that's like too close to your own research.
Yeah. So for me, actually, mine was like a quite different than the work I do, like my research work, but a kind of like work we do in our lab or I did previously in my master, like a kind of catalysis. So like my research is like on TMD, like a transition metal disulfogenides, but my OP was like working on a designing a catalyst, like, and then using it for the catalysis. So like I'm kind of like a way different than my own research at that point, but like it was influenced my previous research a little bit. And also like I would say like you should choose away from your research, but a kind of that topic where you can use most of the techniques you use in your research, and then you can use that knowledge for in materials, like in materials because we do a lot of characterization if you are from material division. So you need a like whatever you are proposing, you have to just propose that like, okay, this is how this technique I will characterize that and all that stuff. So I was like using maybe 1 or 2 techniques were the different ones which I was proposing in my proposal, but most of them were maybe previously I have used them or I have a knowledge or the people in my group use and like you know about those techniques. So like the same thing Lauren said, like the 1-pager I think so is now a very good thing. Like instead of like working like writing the whole your OP, you just like send them a 1-pager and they will most of the like I haven't get any feedback, but most of the people, like if you are very narrow, like very close to your research, then they will give you definitely a feedback or ask you to elaborate how you will say like this is very different or a kind of away from your previous research, like as I did my master. So because you're sending your CV and all that stuff to them, so they know what you have done already. So that's why like be a little bit like don't be like, even though I worked like with the MOPS in my master's. So I didn't choose that topic because I have worked that already on that. So like, but you can just try to be away from your research. That helps you a lot during your oral exam. But also try to use your previous knowledge also in your new topic. Otherwise, it will be too much for you to study new thing in a very short time.
So I think we can go ahead and take another question. Go for it.
What's one of the bigger mistakes you guys made on your OP, and what advice do you guys have to avoid making same mistakes? I can start.
You know, it's not kind of I have a thing.
I was under the impression like I wanted to do my OP the end of September, and so by May this time I was already planning it, and I thought I'd lock down a topic, and for a whole month I spent like so much time just studying one specific topic, loss. And so I spent so much time just studying this one specific topic, and then come to find out I actually hated it. Like, and there was no way that I was gonna ever do my OP on this. So last minute, I like turned the car around and like was writing a whole meeting one pager on like something. So I think by that I would say don't nail yourself down to some topic like too early on. Keep your like perspective open and keep your mind open. And then when it comes time to turn in that one pager, then you can like actually lock down, be definitive of what you're gonna do. But yeah, don't pigeonhole yourself to one specific topic that you think like was gonna do it for you.
Yes, I'm also so for my OP, what happens is initially I choose one topic. So that one was way more like way less like fundamental and more like, okay, we can probably do this techniques or this techniques because I'm from analytical division. So I was thinking like, okay, probably I can merge some from ELISA or something. But then when I sent that one pager, it just turned out like the OP is fine. I got corrected, but the major correction of that was like this is not really fundamental. This is more on like method development. This is more like on like how you do the sample preparation or method development or something like that, which is actually very hard to defend. So my PI directly told me that if you go with this, then probably they will gonna ask very nitty gritty questions. So you're preparing for an OP that you are not working, right? So you really don't know what's the actual challenge in the experimentation that we're doing. So then I turned the OP exactly 180 direction, and then I proposed a whole new method like a instrumentation perspective, but take it totally different direction. And I wrote my one pager and then wrote the whole OP. I didn't take too long. I scheduled my OP very earlier, so I think that's also a good thing to do because you are in either way thinking about your OP, doing your one pager. The faster you do, you have more time later on. You're wasting less time. But also be careful, right? Especially with analytical division, I know like for example, I'm from a mass spec group, so I was told that I was not supposed to do anything related to mass spec. But then what should we do? Like, so be careful, like how you are choosing your OP direction, but still be open. Be very, very open that you may need to change. Don't be ridiculous.
I wouldn't say I made a mistake like that something, but the thing they mentioned is like I think so maybe I did a little bit clever thing. Is like I was having the three options when I started doing the OP, so I was like not so I know I want to do catalysis. Like that thing I know from my start. Like, okay, maybe this the thing I have to go. But on that direction too, I was like looking for maybe some biomass catalysis using like a biomass or some maybe like a zero then I figured out okay which type of the catalyst I want to do
when I picked like one, like I was having two choices, maybe a spotted catalyst or maybe a zeolite chemistry. So yeah, the same thing is like don't be like from the start, I would say maybe you should start with having at least two directions for you, at least two sides when you are like thinking about the things. Because sometimes when you pick an idea, then everything you are thinking and you are discussing with anyone else, then you will every day you realize, oh, this is like a weird idea. It's not gonna work. Even though you are nearby your okay, like that happens with me. Like every day when I study more, when you study more on that thing, you said, oh, maybe someone has done this. I don't think so. It's a like a real gap. So that's why I always have like a two, at least two from the start before you yeah, done with writing your one pager, like when you are sending, I think so at the end of the August, you send your one pager with your all the annual documents. So you should at least have a two ideas. And then that I think so the good thing is to discuss that idea with the other peoples, maybe around your lab or your friends, like, oh, I am thinking this. Do you think this makes sense? Because sometimes you are not paying attention to that side of the topic, which other person can ask you a question. And then you realize, oh, yeah, I have to pay attention to this thing too. So
that's a very good point. So when I switched my OP topic, that was like literally 4 weeks before my OP. And when I supposed to like complete my write-up, like I need to send my write-up in 2 weeks. So that time when I was changing my topic, I actually reached out to Jesse because I was doing something chirology. And then I reached out to another postdoc with Jesse Bin. So they were very helpful because they are actually expert on that field, and they were able to give me actually what are the drawbacks that I need to address when I am solving. So people are very helpful. You just need to reach out, give them time, and like have patience with that. But definitely, you should reach out to people so that they can give you some opinion. And that is really important. Really important.
Yeah. And I also have a kind of like a, and not necessarily like a mistake, but generally, take it with a grain of salt. But because this, I'm in PChem, and choosing your OP topic can also really depend on who's in your committee.
True.
So, for example, I choose a topic where none of everyone knows much about, so and kind of like pursue with the stories, because you know you're like only limited with time on how deep you can get into the topic, and sometimes the professor are kind of generally just curious about your OP. So when they ask question during your like actual presentation, if you choose a topic where none of them really know much or none of them really done before, those questions are more like surface level and kind of just easy to answer versus if you like pick something that your community is like well known about, they might like actually they're not probably not just like ask you hard questions so they want you to fail. It's maybe they're just like genuinely curious on like this new topic that you propose, but unfortunately they know too much about it and you don't know how to answer, right? So that is one thing. And also for your, I feel like for the research part, a lot of people will make mistake. When I made my first version of my slides, is that I focus a lot on like the details because that's what you've been doing, right? Like you, when you're actually doing research, you work with these details. But however, the professor don't want to hear those. I think I ended up only having like 3 slides at the end about my results, and all my like 15 other slides is mainly like the big pictures. Like, how do you want to tell your stories? That's like a very key point, at least in the PChem division. Professor really like ask you hard question on your research, and they focus a lot more on the research part rather than the OP. Kind of just like as long as you've done like to the standards, they'll let you go. But for research, they will actually ask you about fundamental theory, fundamental questions, like if you're doing stuff in like quantum side and you're doing stuff like in density matrix or like basic quantum like Schrodinger's equations, these kind of basic concepts, you need to be able to explain it in a sense where you like everyone can understand. That's what they're looking for. They will not ask question on like how did you do this training in machine learning. They don't really care about that. They care about like how do you sell your idea? Why is your idea important? Does your story make sense? And they will ask you a question like a fake defense, right? Like there's other method. Why do they want to use your method? They will ask question like that versus like, please explain this data from your slides. So I will say the one big mistake that you should like control yourself on doing is putting too much results and your experimental detail on your research talk rather than having like a cohesive general story on why your research is important. That is like kind of the most important part.
I will say really quick, it is 2:45, so if anyone needs to leave for any reason, feel free to. We'll keep going for another few minutes just because we were kind of behind in schedule. But if anyone needs to leave because it is 2:45, feel free to. But I think we'll also take another question.
And first one, do we meet with the committee individually? And let's set like group meeting for all the committee members. And the second one, if the lab is still establishing, what is your advice to get more to know about the techniques we can do, the essays, can we talk to other labs, or how we can like get more familiar on since
In general, you can always talk to like I think talking to other people is like the best thing that you can do for your OP. So like talking to other PIs, talking to other labs, all that kind of stuff, like getting advice from other labs is one of the best things that you can do for your OP.
Yeah, I mean, so I think it's probably way easier to just meet with committee members one-on-one, except for the actual day. People are very busy, and that's can be very, very hard to schedule them, so scheduling together fine, probably hard. And generally, meeting with one will help you orient for what you need to do, what you might need to change. You said you're in a new lab, you're like the lab's just setting up.
well, it's actually for some time, but I'm new in the area that I'm doing, and there's no other group that's doing the same thing. So I'm somehow establishing the areas that I'm working in. So I don't have anyone or lab mates that can help me with the process.
Yeah, then talking to other people who feel at Purdue. Obviously, I mean, everyone's going to read like literature. Reviews might be very, very helpful in general for writing your OP as fine tuned.
No,
I
would agree with that. It's like if you can just talk to him, even if it's from like another division, they might have a different viewpoint on a similar or same topic. That just that different point of view, just like over your head about your ideas or whatever, information on it. So yeah, if you've got, other people you can talk to around in the department, or even just like reach out. A lot of times folks are sick and tired of just sitting in their office all day, that actually a human being coming and talking to them is like, oh my God. So yeah, when, like you said, maybe reading some reviews, and then if you meet with someone having maybe some questions on those reviews, like write down to like ask about in a one-on-one meeting, that's
I think we can go ahead and take another question. Yeah.
So like, I feel like when I've talked to senior students about OP, everyone just talks about the actual like OP part of things and like, what concept you're coming up with and this and that, and that's like all the struggle. But I feel like I don't hear anything about the presentation of your actual research. But I felt like that was heavily emphasized today about John with the
so research is the easiest part in the sense of that's why you've been bleeding, sweating, crying over for the past year and a half at that point. So if you don't know, let's back in and be in a little bit of trouble. I mean, it's what you're doing for 60, 70, 80 hours a week, however many days, rain, shine, sleet, hail, snow. Unfortunately, it's what you know. So it's really at that point when it comes to presenting your stuff, it's just, she was saying earlier, just how you want to present the story. So it's I know when I was putting together the slides for my OP, when I was sick and tired of looking at my OP, I would move on to my research slides because I'm like, oh yay, stuff I know. So it was like a nice little treat from dealing with OP stuff. So it was like a nice little sweet treat to myself dealing with research. So it's honestly, to at least me, it was to your part, So it was kind of just like whatever. Like I would specifically hold off on doing it because I knew it was good to do. Yeah. Oh, you can go.
I think on that note, the few people who I knew got a conditional on their OP got it because of their research. I agree. Same for analytical division. I think the few people I know, they got conditional or got like almost about to fail, that is because of their research. So I think on that one, it's you should have a good your PI definitely know what you are working on, right? So if you have like most updated, like he or she will be the savior on that part, definitely. But also you should be prepared enough to talk about your research, right? So you should prepare yourself on that one.
I will also make the opposite point to that of like, I pretty much they didn't care about my research part. So like that was probably so that like wasn't the reason I got a conditional pass. It was more based on my OP. So I do think part of that is also based on like who's on your committee.
That's true.
So like don't worry about like your research fully making it fast. I think that's also a good thing to like ask to your committee members of like how much weight are you putting on this research part of it. I personally barely even presented my research because we didn't even get there. Yeah, we were like ran out of time.
I think it depends on the committee. It's committee because in material divisions, because we all of the students before giving their OP, they are presenting their research in a seminar. So most of the people, if you have a committee person from your from the chemistry department, if both of them are from chemistry and material division, definitely they will be in your research talk and they know all about your research and they have grilled you already on your research. So they will be mostly on your OP. They are making a decision to pass or fail you. Like for material division, I know because before your OP you gave the research presentation. So for me also the same case. Like because I was having a one OP member from chemistry department and one from a material engineering. So I just go through I was having my slides like mostly of them were my research slides because you gave in your spring your research and then in a summer you are just giving your OP. So there were maybe some of a little bit of the updated version of that my research seminar I presented, but that was like a very fast, I would say, like 15 minutes or maybe just the 10 minutes. I just go through my slides because the other professor because your PI also definitely say that. Like we will go through that, but it will be a little bit fast to give your committee an overview what you have been working from the past 1 year or 1.5 year. So because Jinjo May was one of my committee member, he was in my seminar, he knows each and everything. He doesn't care what I was saying at that point because he know all that stuff from my research seminar. But the other professor, he was a little bit interested. So I go through but very fastly and he asked me like a couple of one or two basic questions. But it's like a committee. If they are passing you, they are fine and happy with your OP talk, they don't care about your research talk. But the good thing is it's like a part of your exam. So you should be prepared because you don't know what happened that day. So I would say like seriously, like you don't know what happened that day because so you should be prepared for both parts, I would say. Because now most of the professors also say like that, like both we are judging you on both parts, your research and your OP. So I would say be prepared for that because no one knows what happened on that day and who is in your committee and what they are thinking.
It is also worth noting to that point that like the research part of this has only been mandatory for this is the second year that it's been mandatory.
Yeah, from the last
year. So a lot of the like senior graduate students that you'll talk to above like the third years, they might not have even presented any of their research in their OP.
Yeah.
Sometimes it got skipped entirely.
Yeah.
So I would also like ask like a lot of your third years how their research played into their OP because we're gonna have like more of an idea.
Yeah, because I was like for the PCAM division, since we don't have the seminar to really talk about it, so they really kind of focused on the research side rather than the OP side. So I guess that's
it depends on division to division and professor to professor.
So I would say if it's a part of exam, take it as a exam. To be safe.
I think one point
like no one
again and again that you should know your committee. One thing that I did, I knew like the people who are in my committee, they were in previous students whose committee they were there. So they kind of give the vibe. For example, I have McClatchy in my committee. So I asked someone who had McClatchy in their committee, and they were able to say how he actually asks questions or which kind of things he is actually interested in. So these are something that is I think worth to like look for or look forward. And also I have someone who is really out of analytical division. So from organic I had Dr. Lau. So I also talked with people who had Dr. Lau in their community who usually ask questions from the own curiosity. It's not could be in a field. But just knowing that factor actually helped me. Like, how should I prepare for this?
Yeah, so she's right. Like I also did the same thing. Like when you are done, I was done with preparing my whole slides, like which I am gonna present on my OP. I took those to the people I know in my committee members lab and asked them like, these are my slides. I will go like I just give them a brief, like, okay, I'm just gonna talk like this. It's very informal, like a presentation to them. And I asked him, like, what do you think? Your professor is gonna ask me from that because they know their professor very well and they like in a different settings. So they also give you very good idea. I think so that was very helpful for me. Actually, I got like most of those kind of questions and I was like mentally prepared before that, like where I am gonna have a hard time and where like and how I have to defend that. So yeah, so that's a very good technique. I would say if you are done with prepare like practicing with your own group, like with your friends group, or your like you have your finalized version, just take that to the someone you know. If you even don't know, you can just go. I think so every grad student will help you if you just go into that tab and you say like, oh, I have my OP coming up and like your professor is my committee member, so can you just see these slides and like give me an idea what he or she can ask me. That will be very helpful. Like you will be mentally at least prepared.
All right, I think that's all we have time for today. It is about 3 o'clock. So we'll wrap this up for today. Let's say thank you to our panel once again. Again, all of the slides and handouts will be sent later on today. Hopefully we'll also get the recording up on ISP's YouTube. But yeah, thank you all for coming. And let us know if you have any other questions.
Yeah.